I'm just going to put myself on mute until we start.
We're testing technology in real time. We have 30 seconds. We're good. We're good.
We're good.
Zen. So we're literally testing technology in real time. Welcome to today's program, Engineering for Good. I'm your host, Dr. Darrell Williams, Senior Vice President of Science and Education here at the Franklin Institute. And today we have a really exciting program for you. We have two wonderful techies, I'll call them, who are going to talk with us about the brain machine interface, and we're going to talk about neurotechnology, and we're also going to do a demo. So we're going to get hands-on today. Just a couple of housekeeping rules. Again, have fun. Two, since we are using Facebook Live, you have an opportunity to send in questions. We will do our best to answer them throughout the program. And again, this is an opportunity for you to really talk to some folks who are on the ground doing some pretty high-tech stuff. So I mentioned in the opener about the brain-machine interface or brain-computer interface. And so another way of describing that is neurotechnology. We're actually going to try to unpack what that term actually means. But essentially, from what I gather from some of the research I've done on this to prepare for this particular conversation, and also in conversation with our guests, is that it's really looking at how we use the signals of the brain to control and manipulate technology. So I'm going to sort of stop there, and I'm going to introduce our guests so that they can have an opportunity to chime in. So with me today, I have two really cool gentlemen. First of all, I'll introduce you to Josh Valera. He's the Associate Director of Strategic Partnerships at BrainCo, and he's also accompanied by Andrew Banish, who is the Neuromaker STEM Product Manager. Welcome, guys. How are you?
Doing wonderful today. Thank you, Darrell. It's a pleasure to be here.
Absolutely. Very good. So let's just jump in. We have a lot to try to cover in the short amount of time we have together. And so I'd really like to, again, maybe start off, if we could, with our guests and really sort of define what does the term neurotechnology mean? How do you define that?
Yeah, I'll take this one, Andrew. So neurotechnology and brain-computer interface at first is literally understanding how the brain is able to interact and control other applications around us. And how we apply this technology in what we're doing here at BrainCo, we look at neuro-optimizing different industries and different partners. So one of our biggest partners within this is Formula Racing, Formula Medicine. And we actually look at their drivers and their neuro responses as they're going through these long drives to determine how they can utilize the least amount of mental energy to have the most optimal performance. So that's just a real world aspect of how brain-computer interface neuroscience is being applied within different businesses and within different areas. I'm going to pass it over to Andrew right now as well to give you some of his insight on this subject.
Sounds good.
Absolutely. So Josh just gave a very good, vivid example there. I think the more kind of boring answer to that question is really neurotechnology is any implementation of the science of the brain and the neurons in order to power or interact with some kind of a device. I think a lot more technologies out there that you may be familiar with fall into this category. Things like MRIs in the hospital, all kinds of different EEG devices. So actually one of the devices that we have here and be happy to show everybody later is an EEG device. So these are special sensors that go onto the head, and they're able to measure out those brain signals that Josh just mentioned. And there's this whole really interesting science around finding the kind of signals that you're looking for, being able to make some kind of inference from the materials that you're getting, and making that fit appropriately into some kind of application like Josh said. So there's a whole wide field of these different things, and like what we investigate here is just a sliver of it.
Right. And could you actually, just for the audience, could you define EEG?
Sure. So I'm going to try to say that I feel like I've been practicing this word for a very long time. So I believe it's pronounced electroencephalography. So, and this technology has actually been around for quite a long time. It actually started off in the 1920s with a guy named Dr. Hans Berger. And it's simply being able to measure brain electrical activity from the scalp. So there's all kinds of different ways to detect signals from the brain. We typically parse those out into invasive and non-invasive. So in this case, EEG is non-invasive. You don't need to put anything inside of the brain. You don't need surgery. There's other more in-depth technologies that require an actual surgical operation to put some sort of a sensor in the brain. But EEG is simply putting an electrode on the forehead. There's all kinds of different medical and consumer applications of this, and the technology has really evolved over the past 100 years, particularly over the last 20 or so. And what you might have seen in the hospital, where people have those electrodes there and the gel, really evolved into something that you can wear on your head now. So there's a lot of really cool applications of this, and we just have a piece of it.
And that's really fascinating. So how then, and we can get into the specifics of this as we start to, walk through your product and do the demo. But I guess, how do you then take the signal, the brain waves, the brain signals, and convert that into, a programmable language that then a piece of technology or what have you actually responds? How does that actually work?
Sure.
So thank you, Andrew. So it's actually pretty amazing. What we are able to do here using our sensor technology. So we use a semi-wet sensor, and pretty much, thank you, Andrew. That sensor is looking at your raw EEG signal on your frontal lobe. And through our machine learning algorithms that we've had developed in-house, it's actually then able to create a data point which is able to give us a representation of the current state of the individual. So back to that race car Formula One example, let's expand on that a bit. It's pretty much able to, within a second, look at if their brain activity, all their alpha beta waves are spiking, or if they're in a relaxed, calmer state. And then through our machine learning process is then able to give you a linear definition from 0 to 100. And from there, we're actually then able to surmise and understand what the individual's brain activity is going through in correlation with the activity they're doing.
And you use the term machine learning. So there's actually which is related to artificial intelligence. So the intelligence that's being developed here or designed here is really learning along the way. Is that how this works? And so then it becomes even more responsive to the user. Is that how that works?
That is 100% accurate, yes. So the algorithm will learn about the individual as they're going through their process. And then from there through, we have a couple of different cognitive function, executive function trainings that are built into our applications. And it allows at a visual level for the user to understand these activities. I'm also going to pass it over to Andrew because I know he has some insight on this also.
Sure.
Yeah, and I think another way to put this into another format is like looking at what goes behind all those amazing things that Josh just mentioned. So in particular, thinking at this as an electrical device, like what you really see is the staple of these different kinds of BCI technologies is taking in some kind of an analog signal, like those signals coming out of the brain. So in this case, your brain is made up of billions and billions of neurons, and they're all firing, doing different things. So figuring out which clusters of neurons are firing in what places of the brain, you can make some inferences on those different things that Josh just mentioned. So typically what you want to do is have these different sensors pick up those different changes in voltage. And then through the machine learning algorithms that we just talked about, you're able to figure out like what those different electrical signals are inferring. So I'm sure you've heard about different brain waves, right? There's alpha waves and all those things.
Right.
Yep. And by combining those different things together and looking at the responses that you have to certain stimuli, you can actually figure out what kind of a mental state you're in, your relaxation. And that's just the consumer end of it. There's also all kinds of medical things that you can do to communicate with people, control different objects. It's turning into a lot of really exciting projects.
It certainly is. It sounds like something from Marvel, Marvel Comics. I have a question that's come in from the audience. It's can't you already, or can't we already get EEG at the hospital? Would this be cheaper or able to be done at home?
Yeah. So EEG at the hospital, when you're going to meet a neurologist, they're doing 18 channels. So they're actually mapping your entire brain, and they're looking for something medical related. Where neuroscience and brain computer interface is headed is into a different direction, where how do consumers or other groups and other individuals utilize this similar technology within an at-home way to either be applied into what Andrew's saying, moving or powering an object, helping with mental state, helping with cognitive function. How do you take these technologies which have existed within other spaces, and how do you reevaluate them and reincorporate them to help improve daily life and or mindfulness activities?
Interesting. So I think this is actually, so this is a great segue to the work that you all do at BrainCo, because essentially what you're doing is taking this technology and applying it to upper limb prosthetics. And so I'd love to kind of talk a little bit about, how that all came about, and then we'll then jump into the nitty gritty with your new product that you've just launched a couple of weeks ago, and take the audience through that. But first, let's talk about, the inception of BrainCo. Like, how did BrainCo come about?
Yeah, it's a great story. We got our start out of the Harvard Eye Lab 4 years ago from today, and what we as a company were doing back then was brain-computer interface. We're based on the foundation of neuroscience. We were at a venue. We were at CES, and we were utilizing brain-computer interface to move objects, to show people how you can turn on a light switch. It can be utilized to actually move a toy car around a track. And then an amputee came over and said, "Hey, can this be utilized on a prosthetic?" And being a bunch of Harvard educated engineers and some really amazing writers of software, they said, let's give it a whirl. Let's give it a try. They found EEG wasn't the best technology to solve this problem, but they knew it had to start somewhere. So EEG then led to us creating our own EMG sensor. So our EEG sensor, which is found on our wearable, was reutilized for prosthetic arms. And that is actually using EMG, electromagnetic cardiogram. So pretty much the nerve pulses that you're creating naturally. And an amputee, what we've been able to do in this space is really groundbreaking. Most prosthetics that have unlimited gesture functionality have the ability to learn and get better with a user. Their upward spend is six figures plus. But what's the good of making robotics? What's the good of making these groundbreaking technologies if it's not accessible? So the team worked tirelessly to reduce that price point to a $15,000 price point, where an amputee within 5 minutes can learn open and close. And then within 30 minutes, complicated gestures, to the point now our early adopters are rock climbing, they're drawing, they're able to drive again, utilizing the same groundbreaking technology, which came from how does the brain control everything? If we can understand how the brain works, we can figure out ways to help amputees around the world by using our own sensor technology. So that's the inception of BrainCo, how we did what we did in terms of prosthetics, but we also do some amazing things in education. And I'm going to pass it over to Andrew to talk about how these endeavors collide.
Right. And actually, before you get to the education piece, I just wanted to ask you just this one other question too, right? With regard to the design of the prosthetics, are they designed to specifications of the intended user, or in other words, are the components customizable, or are they just sort of assembled generically, for lack of a better term?
Yeah, great question. So there are different sizes that we do make for the hand, and it's a modular design, so you actually can take it apart. But the key to the prosthetics actually comes down to the sleeve. So the sleeve is one of the most important parts that does have to be customized, that has to be fitted, that has to be measured. So the hand itself, we have different sizes for younger users and for users who have bigger hands, things along those lines. But the sleeve is designed to be customizable. And that's where you see the real impact, is when they're able to get something fitted perfectly to them.
Right. And so then how does your particular technology stack up against the competition? Are you, how, if you had to rate yourself, where, because you just said in your description that you've significantly reduced the cost associated with not only producing these, but also, at retail. So, what does that mean for the market?
Well, not to toot our own horns, we actually were featured in Time Magazine's Top 100 Inventions for 2019. And for us, we actually just started an amazing partnership with a former vet, Carrie Duvall, and we were just featured in the Washington Post right before the new year. So for us, we're really groundbreaking within the space, because we're taking technology which has been around, we're reevaluating it, and people want to think of innovation as a giant leap. Innovation is just being able to look at something and say, okay, we can do something a bit better and at the same time a bit more affordable. So all the parts that actually go within our prosthetic, 97% of them are already FDA approved. They already have been a part of the marketplace. Where the magic really comes to life is in the machine learning and the AI capacity of our prosthetic, and of course our sensor technology. So that's where we've been able to truly break the mold. And that's our goal, is to really spread awareness of how these prosthetics can change people's daily lives.
Interesting. So yeah, so BrainCo, as its inception, you make inroads in this technology, and then you have this epiphany that you can not only affect, the upper limb prosthetic world, but that you also have an opportunity to make an impact in STEM education. So segue to Andrew. Andrew, how did that come about?
Oh, I always love answering this question. I think simply put, I mean, you heard all these really incredible examples from Josh about working with Formula One racers and using this kind of technology to help amputees. And it's just from people coming out of the STEM world. I think the question that we're always trying to solve is, how can we prepare people not just to gain lots of technical skills, but also to really learn how to apply those and think outside the box to kind of generate these new ideas. So what we really saw as an opportunity to use this storytelling device to take these different experiences that our engineers had, tackling some of these bigger issues in their society using technology, and bundle those into experiences that you can live in the classroom. So what we really wanted to do, what we have been doing, is taking these two different pieces. So the way that Josh mentioned it was perfect. The EMG technology based within our prosthetic hand, and also the EEG technology inside of our headband. And how do we use those two products to tell that same story through the students that work with us, and get them in the mindset of being an engineer who can tackle those problems.
Very, very interesting. So I actually tried to, I was fortunate, folks, to get a kit from BrainCo, and I realized that it does not come with paper instructions. So you do have to read the QR code, and wasn't able to get all the details, but I did start stringing together. So I have, some pieces here, but really it's such a fascinating technology and STEM education tool. Just from, as a basic question, how long does it take to actually put this together?
I'll have Andrew field that one.
Okay, yeah.
Yeah, I just have a finger.
We came prepared. We wanted to make sure that everybody got a chance to play around with it. So it really depends on what kind of learning objectives that you're looking for. So if somebody really sits down and pieces everything together, we're probably looking at a few hours. If you want to go through all the different, like within this kit itself, and I'll show you how the technologies interact. We like to parse this out into different learning modules around electrical engineering, biomechanics, and things like that. So the build can actually be customized based on which of those elements that you want to focus on. So we actually have a whole week-long curriculum centered around learning all the different side of the kit and how to use those.
And just to be
And
clear to the audience before we keep going, that the technology that you're demonstrating today is the actual STEM kit as opposed to the actual prosthetic that patients can use, in the real world. This is a simulation of how an actual prosthetic can be designed and programmed.
And to give a bit of insight on that, the Neuromaker hand that's in front of you actually was a prototype design by our engineering team. So so it was a prototype, and then we looked at it from an educational lens, and we said, well, what are some of the core learnings that are found within this build, within these understandings? And Andrew's team has been phenomenal. For us, as a tech company going into education, we've always asked ourselves, what can we do differently within the classroom? So what comes with the kit is actually a whole educational bundle of over 60 hours of curriculum that's aligned to NGSS, CT standards, ISTE standards, but also there's a creative challenge piece to this as well. There's a coding platform. It's also open source in design. We did that on purpose. So we want schools to tinker. We want them to reimagine it. We want them to 3D print. We want them to push the limits, because at the end of the day, innovation is going to come from the next generation of students that are in the classroom right now. And we look to students to be the innovators in the space. And to Andrew's point earlier, it's about creating those career connections, those ideas of saying, okay, we have something very approachable with the human hand. Everyone can realize and see the beauty of the hand. And at that same time, it's also about getting STEM into a point where it's more accessible to a wider population of students. STEM is intimidating. As people who have been in the field, getting into the field is very intimidating. So we really wanted to create a solution that anyone who is either a STEM rock star can love and do what they want, but also that someone for the first time who wants to learn the foundations of coding and of course project guide assembly can go through that experience also.
Wonderful. So let's try to do like a demo just to kind of show folks how this all works.
Yeah,
sure.
So and I have my very crude demo.
That's okay. I mean, there's a lot to learn even within that too.
There's a lot to learn even with this, right?
Yeah. So sure. So I'll just walk you through a couple of things that we'll be looking at so we can put all these things into context. So I actually have two different things that we showcase to show these principles that we mentioned. Breaking down these pieces of brain-computer interface, advanced prosthetics, all those different things. So the two big pieces, you just saw this. This is a EEG device, so we call it the Focus One. And just as Josh was saying, we wanted to bring in those actual elements from our engineering team into the classroom. So the kit you just saw that simulates the prosthetic hand was our actual prototype for our brain robotics hand. And this headband itself is our actual consumer grade EEG device that we use for focus training, meditation. So it's the actual device. It's not like a whittled down piece of technology that students get to use. It's the actual thing that we showcase in all of our different use cases. So here, just so everybody has a base understanding of it, it has 3 electrodes. So these are going to be placed on different sites on my scalp, and those will be able to read the differences in voltage between all of my neurons firing inside of my brain. And the real magic of this technology comes really with the processing. So what happens with a lot of EEG is you're going to get a lot of raw signals, and you have to really find out, what are the things that I want to focus on. So which brainwaves do we want to focus on? Remember, it's measuring all those different electrical symbols. So when you think of how faint those signals are inside of your brain, they're combating with all the other signals coming from moving your muscles. So every time you move your forehead, that's going to create different electrical signals from your muscle movements. The different electricity inside of your house is going to also create kinds of interference. So really being able to get out all the signals you don't want and focus on the ones you do want is the real key to this stuff. So
and is that what it's called, noise? Is that what
yes.
you just call noise? Okay.
Yes, and noise is sometimes artifacts, so depending on the thing that you're focusing on. So I'm actually going to share my screen.
Okay.
What some of these things look like. So I'm just going to walk you through how it's all set up. You will look at my messy desktop. Okay. So, yeah, so what I'm going to show you are 2 different things. So here, I'm going to set up the focus headband so you'll be able to see my brain waves in real time, and you'll be able to see some of the algorithms that we've developed. So I'm going to be very brave and show you what's happening inside of my brain live and see if I can make some things change. So I know Josh will do the best not to make fun of me and change the results, but you never know. And then also in the background here, I have a very simple program set up that I'll walk you through where you some of the signals that are coming from this device. You can use it to control our model prosthetic hand, our Neuromaker hand.
Right.
So you'll see like the real foundations of BCI. With that, I'm going to get this set up. I'm going to turn this on.
So as you're setting that up, what is the cost of this kit for the average consumer?
Yeah, so our Neuromaker hand, we work with school districts all throughout the country. They retail for $500. That includes your curriculum, your build, your 3D files, the coding platform. They're a 2-to-1 ratio. We want students to have that very authentic engineer moment where you're working on a project. And we've been working with a multitude of school districts around the country. And for us, it's about getting our technology where it's best needed, and that's within K through 12 education. And then for Neuromaker BCI, which Andrew is bravely demonstrating right now, I see your brain is working hard.
I see his brain is working as well.
He's got it. And then for Neuromaker BCI, which also is bundled with curriculum, a coding platform where students can look at this amazing dashboard, that retails for $400, and that includes the great curriculum, the EEG technology, and this platform that you're seeing in front of us, where students also have the ability to code and create their own brain-computer interface applications.
And so this is so middle school to high school students are is that those are the grade bands that this particular toolkit is aimed toward?
Yeah, we've been working with middle schoolers and high schoolers, particularly with these technologies. And what's really amazing about our curriculum and also how we presented it, there's a lot of flexibility and functionality. So we don't believe in cookie cutter. Every school is different. Every school has different needs. So our curriculum works really well in tangent to ensure that this is getting to the student populations over a wide variety of classrooms and over a wide variety of courses, because we need STEM to be approachable and we need it to be accessible. So as thought leaders within this field, this is what we're doing to change how ed tech solutions are being brought into a K-12 environment.
That's really awesome. All right, Andrew, so you're all fired up here. So what are we looking at?
Sure. So I'm going to walk you through what we're looking at here. And then once we get through all that, I'm going to set it up so I can connect it to my Neuromaker hand and you can see how those two things play. So first of all, I'll just walk back some of the things that I mentioned earlier about EEG and BCI technology. So first of all, here, I'll walk you through each one of these different portals. So we have 4 different representations of what is coming through the signals being picked up in my brain right now. So the first one is you're getting this raw EEG signal. So we wanted to showcase this so you could see exactly what the kind of data coming through without any kind of filtering or any kind of other algorithms placed over it looks like. And you can see here, it's hard to tell you something except for some basic activity portions. You're just getting a raw reading of the time here at the bottom and the strength of the signal on the left side. And within this, although it looks very imposing at the moment, you can do some things with filtering out different wave bands. You can also filter out the different noise that you're not looking for, and you can run different kind of algorithms on top of that. And after you do all those different things, we have some pre-baked algorithms here that have already filtered out that information for you. So just starting off with alpha waves here. So we've bundled out all the different wave bands into these different pockets. So our first one is alpha. So you've probably heard of these different things. So alpha waves are mostly correlated with meditation and relaxation. So they're inversely related with focusing or concentration. You can see some of the other things here. We have beta waves, which are focused primarily on a concentration and like the opposite of alpha. So what's actually interesting is being able to use those two different signals. That's actually used often in medical context. Ever since 2013, I believe, we've been able to use that in clinical studies with people suffering from different kinds of neurological disorders. There's some really interesting work being done there with ADD and autism. And that's where most of those signals are going to be used. You'll also see there's been a lot of great research done over the past 20 years on applying these things to create meditation and attention tracking algorithms. So just as Josh mentioned before, we've been working with thousands and thousands of people over the past 5 years to collect all kinds of data and make sure that we can tailor these algorithms appropriately. So you'll be able to see here, those alpha and beta waves, along with a couple pockets of some of these other ones here at the bottom, have been translated into a meditation and an attention algorithm. So what we did to make this easier for people to understand is we took different mental states and we put them on an index of 0 to 100. So in the attention case, based on our research, people who are completely disengaged with something, and you can really think of attention in this context is something with a heavy cognitive load. So if you put the mindset of, I'm solving a really difficult math problem and I'm staring at the paper and I'm really thinking, and time almost passes by super fast. So you're in a flow. So when you get into that kind of a state, your attention level is going to get very high. And conversely, if you're going to be distracted, or maybe you clear your brain as if you're meditating, that's going to bring your score down. So that's the way that this algorithm has been tailored. And you'll be able to see here that I'm focusing pretty much straight at a 50. I'm distracting myself a little bit by talking. I'm clearly not, I am, however, engaged. So you'll see between the 35 and the 65 band, at least according to our calculations, is going to be that typical range that we live within. So that's what the attention looks like. And we have the same principles carried through our meditation app as well. So these are inversely correlated. So our meditation will typically be used for if you're incredibly relaxed or you're clearing your mind. They're typically going to move in opposite directions, but depending on the different actions that you're taking, they might correlate a little bit too. So there's all kinds of different things that we can do to make these numbers go up and down. I'd be happy to demo a couple of these for you so you can see how well I can focus and meditate. I will start off by saying I've done a really good job being able to clear my mind and bring my attention scores really far down. I think I need a little bit of focus training. We have some people, all-stars with our organization that can get super high attention scores. I'll do my best for you today, but I'll probably be able to show you the lower bounds of that.
And so now you're going to be able to demonstrate the control of the hand.
Yeah, so what I thought I'd do is, so that's what this GUI looks like now. So there's all kinds of different things you can do with just this interface here. So like depending on the different actions that you take, whether that you're focusing or even blinking, you'll be able to see different kinds of changes in the graph. So there's kinds of experiments you can do there. But I think one of the things that's most vivid and really brings forward what we did from a brain-computer interface technology standpoint is making that power other devices. So BCI itself is made up of 3 different pieces. So there's that collecting signals, right? So that's what this raw EEG looks like. We then have processing, so turning that into some kind of a usable signal. That's what you have here, right? Our attention and meditation are filtered out pieces of information. And number 3 is the control of something else. And for that, we have a simple demo set up here where you can use MBlock. So this is actually a block-based coding system. And I have this set for, this will read the actual attention score that's coming from here. And depending on where that score is, programs to have different gestures. So actually, I've programmed it. So I'm going to bring the kit over here so that if I am getting really, really relaxed, it's going to make a peace sign. If I am in a like a normal cognitive state, it's going to relax with a 5. And then when I get really focused, it's going to go to a fist. So, so I'm just going to recalibrate this so I can pick up that signal. I'm going to turn this on and I'll demo that for you in about 20 seconds.
This is fascinating. Wow.
It's a fun thing to do, and Andrew's been able to do this in some of the most hectic demo environments ever. So shout out to Andrew for that. Trying to get into a Zen state when you're surrounded by 60 people is a challenge for many. But here at BrainCo, we love to introduce mindfulness and wellness into our daily practices. And we're lucky in, something's going on. that brain's working overtime.
That brain's working, yeah. Technology in real time. So I have a couple of other questions that come in from the audience. One is like, how does this work when you have students working together? Is this really accessible to individual students, or like what's the ideal ratio of students to kit?
So 2 to 1 is where, hey, Andrew, you're doing some magic over there. 2 to 1 is where we ideally like to talk about. So for example, if you have a classroom and it's about 20 students, we would recommend 10 of our kits to be utilized. We love for students to have those 4 C's in there. We want them to communicate. Wow, Andrew. As you can see, the meditation dropped and the peace sign popped right on up. It's holding there. Really, really amazing stuff to see. And Andrew's doing this on a live event, so shout out to Andrew as always. So 2 to 1 is where you want to go. We want them to have the 4 C's. We want them to collaborate, communicate. And we've been able to do this within a hybrid environment as well. So we actually have all our materials also prepared for hybrid and even remote, where students are still able to work as a collective, still able to problem solve, and at the same time have an amazing, engaging experience.
So when in a virtual learning experience or environment, is it possible to make it accessible to each individual student, or is that, any thoughts about that?
Yeah, it depends on the district and the regulations they have. So for example, in hybrid, as some schools are currently going through, they'll have some students in the building, some students are at home. And what they're doing is they're actually giving different jobs within the group. So the person who is in there might be working on the engineering, the other person might be working on the coding, and they're uploading their coding. So they're able to collaborate and share. And then for our curriculum, a lot of what is in our curriculum, especially within the biotech, biomedical, and of course, within the life science, the hand is a reference, but the curriculum still has those lesson plans, still has those worksheets, those research that gets involved, the big ideas, because we want students to feel as if they're a part of an engineering team that is doing this within any other company. And as you know, as we all know today, companies are still having to work. They're still going to have to work together, move forward within a virtual way. And we try to replicate that same experience within the classroom during this time. Of course, hands-on together in the room is great, but we all want to stay safe and stay healthy. So our team is able to actually work with districts on how to implement it based upon their needs. So it will look different everywhere because, as you know, every school has and every district has their own needs, especially during this time.
For sure, absolutely. So how are we doing there, Andrew?
He's been doing great. Andrew, if you want
to, are you in a zone?
Well, that's the thing. You don't even have to ask. You can just see yourself. Actually, so as you've been able to see, the way I've tailored it here is that every time our attention score goes below 20. So when I really try to clear my mind, it's going to create that peace symbol. As you can tell, if I'm focusing up when I'm answering your question, so when I have it above a 40, it's going to turn to a fist. And when it's between a 20 and a 40, it's going to turn into like a 5. It's going to be
a 5. Right.
So yeah, just a couple of, and these are the exact same principles that power our, like our Time Magazine award-winning prosthetic. And there's these really cool ways that you can unpack this stuff and kind of relive it through a different educational point of view. So you're seeing like all the magic happen here, albeit just in a more portable fashion.
Sure, and I think what's really fascinating about this is that it really is an authentic learning experience for students. Like you're really giving them an opportunity to understand the interdisciplinary nature of the engineering design and pulling in all these different aspects of the science, the mathematics, the coding, the design piece. It's really quite remarkable.
Andrew, if you don't mind, can you relax a little bit? I want to see that peace sign one more time.
Okay, so there's never, it's hard, what am I trying to say? it's very hard to relax when somebody tells you to relax. So I'll do my best here. I do want to follow up on your comment there, Dr. Williams, and just say, yeah, like authentic learning is exactly what we're trying to go through. We really wanted to take something that was within like the actual engineering space and turn it into an educational experience rather than reverse. So all this is fed into by authentic learning principles. And we're happy to do that with everybody who works with us. So I have been requested to relax a little bit, so I'm going to close my eyes and see what I can do. So you will see my progress here. The farther I can get that attention down is where you'll probably get to see my hand move. So I'm going to mute myself.
We'll give you an opportunity to relax a little bit, and maybe Josh can answer this question. So you all have what's called the Neuromaker Challenge. Can you talk with us about that and what that entails?
Yeah, so the Neuromaker Creative Challenge happens every fall and spring semester. And we pose the critical problems, the critical questions that are facing amputees to students around the world and also in our country. And we segment it through, there you go, you did it, Andrew. I'm proud of you. Look at that peace sign right there. So, and as you can see on the data shifted downwards, really remarkable stuff to see. And what this challenge is really amazing in, we love to have chat with a webinar series. So as students are entered into our competition, which by the way, there's no fees, no travel. It was designed by someone with great experience within this field. And so I'm going to pass it over to the creator of the Neuromaker Challenge to elaborate on it a bit further.
That's right, because Andrew, you have experience in running and being part of FIRST Robotics. So did that influence the design of the Neuromaker Challenge?
Yeah, so I actually ran the first program, or at least many of the programs there in China for 5 years, and did a bunch of international things too. And what we really wanted to do with our like new opportunity here is, I think you hit one of the key words just a moment ago, which is that authentic learning piece, where the one thing that we really wanted to highlight is showing that bridge between what people are doing in the classroom and career. So what everyone in our challenge does is we simply give them this kit along with a couple of other supplementary things, and they are free to come up with any of their ideas that they wish to help people with amputees in any way possible. And so what people actually do is they can spend their semester or their year brainstorming, like finding out different ways and experimenting, and they document that process and they submit to us a video. And we actually have the people who created that original prosthetic and our BCI scientists review each project. So everybody who creates something is reviewed by our internal team here, and it goes through the same engineering review processes that any of our new products would have within our organization. And we actually just wrapped up the first iteration of the challenge in a remote learning situation. So what's actually interesting is we really put this together a little over a year ago. And at the time, we were working with a lot of schools in Pennsylvania and rural districts who typically aren't close enough to a STEM competition or don't have the funds to get involved with this kind of stuff. So we really wanted to make it really like cut out all the overhead. You can submit a project completely online. Like you don't have to go anywhere. There's no registration or anything like that. And then of course, when COVID happened, like we were pretty well prepared to handle that kind of like a learning environment because anyway. So if anybody's interested, we have information online, and it's always really exciting to see what students come up with, like when they can help out others and think in a more socially conscious frame of mind.
So we spent a lot of time in this conversation talking primarily about students and the focus at the student level. I'm curious about any insights you have on working with educators in this space, and any, what's been some of the feedback that they've provided in terms of accessibility and their abilities to actually grasp how to use this particular tool or technology in their classrooms.
Andrew, I'll let you, because you talk to the educators a lot, and so you have some great feedback to share, to say the least.
Sure. So I think that the easiest way that we've approached that kind of a question is, accessibility like has a number of different parameters there. And one of the ones that we saw as a common theme with all of our STEM work is everybody who's working with this technology is all facing different levels of experience and technical proficiency. So one way that we really wanted to approach that is through the design of our hardware, you can actually have either a scripted kind of STEM experience. If there's teachers or students who are brand new to this space and they don't want to jump into anything posing or maybe difficult, no worries. So like we've been able to approach things that way where there's things where people can take it right out of the box and start to move around. We also have given an opportunity for those who want to take things to the next level. And so for instance, like our Neuromaker Creative Challenge, we had students, I'm gonna say a shout out to Perry Central High School, who put out some amazing sensors. They actually custom printed 3D printing or 3D printed digits to the hand here. And they installed their own piezo sensors to take different pressure readings, which would be similar to what our processors do in the lab here in order to touch very delicate items or anything like that. So there's like we try to provide a range for what people can do with the materials that they have, and not, one of the things that always bothered me, I should also say too, that anybody who's listening to this from the STEM environment and kind of overloaded by everything, I completely understand where you come from. So I am not an engineer by trade. I had to learn everything from scratch. I was actually an international relations major and had to figure out this stuff on my own. So one of my lodestones to all the things that we put together is I like to be a professional idiot. And if I can do it, pretty much anybody can do it. So we've kind of taken that through what we've been designing with everything from BCI to our hand. Like
Andrew, it's called lifelong learning, right?
But yeah, maybe I should. I can think of some other ways to word that. Maybe I need a better. But yeah, I think like we mentioned, we like to provide that range of what people can do, and if people want to take things to the next level, they're more than welcome to. Otherwise, we're happy to just make sure people have a good experience and really stay engaged with what they're doing.
And one thing I, of course, would just love to add to all this is, Andrew's team has put together a curriculum which is able to fit the needs of each district. So for example, let's say, that middle school program, they're trying to get it established, they're trying to get those fundamental skills in place. And at the same time, though, they have a high school that's doing biomedical and biotech. So with the same technology, we're able to tier the learning experience to match the needs of the students and of the educators. And in terms of our portals and our resources, on our website, neuromakerstem.com, what you're able to see is, with our curriculum portal, a very easy to use, easy to understand breakdown of every single lesson, the scopes and sequences that go along with it. And what we tell educators when we're speaking to them, you can utilize what we have here, or of course you can edit it to address your existing programming, because we understand time is always of the essence for educators. And when schools have to think about programming, it's always something difficult. It's a 30,000 feet view, but when day one, when it starts in the building, it becomes a bit more challenging. But what we love to do is provide resources, materials, and alignments that can really take this same technology and have it live throughout the whole district and throughout the building itself. Because we want more students to be able to have this hands-on learning experience. Because at the end of the day, if we're able to at least get one student to go on and create the next great prosthetic, and they start their own company, then we did our job. And that's what we really want to do here, is get more students to think about these STEM careers. Because as we all know, technology is everywhere, and we need our students to be thinking about the future and how they can be a part of the innovation.
So what's the best URL for people to use to learn or inquire about the kits?
Yeah.
I'm gonna type it in so that our magician behind the scenes can put it up in the chat for folks. What's the best link?
Yeah, sure. I'll pass it over to Andrew because it's his baby.
Sure. So neuromakerstem.com.
And you'll be able to see samples of our lesson plans, our curriculum. You'll also be able to see some of our other webinars that we put together as resources for educators. And of course, if you need to contact or reach out directly to myself, to Andrew, we'll be happy to get back to you and have a great conversation on how we can be a part of your initiatives and become a part of the Neuromaker family.
This is great. You guys have been great. So I have a fun question to ask you guys as we close out. Since you both are living in this world of brain-machine interfacing, brain-computer interface technology, neurotechnology, and in the prosthetic world, I'm going to pose a question to you and see how you guys respond. So, which one of you would win in a robot against each other? Which one of you would win in a robotic arm wrestling competition?
Well, I'm the only one who has one right now.
Oh, so wait, you have an unfair advantage.
Yeah.
Or maybe you don't, or maybe you don't.
Well, if we have to use, it depends on which algorithm we have to use. So if it's the meditation side, I'm not going to sound boastful, but I think I got it. If it's the attention side, it's 50-50. That's how I look at it.
Doctor, what are you trying to do to us here? Is this
just a little friendly competition. No big deal. No big deal.
Yeah. I will really take Josh on in a meditation contest any day of the week.
That's great. This is good.
You have my word.
No, you guys have both been great. So I do actually, just for folks' sake, I do have the kit box here, just sort of so you have a general sense of what it looks like. They've done a beautiful job in terms of making sure that it has all of the things you need to put this stuff together. I've got a whole slew of products and components over here to the side. Again, I made an attempt looking at the time-lapse 2-minute video to try to put this together and then realize that I could only go so far. So I'll have to connect.
We'll make sure you get the right materials.
Well, yeah, it's a real fun build. It's an open source design, so there is an Uno board in there, but if anyone likes to plug in.
I want to close out, and again, folks, if you're interested in learning more about this technology, please check out neuromakerstem.com. You can send all of your, I believe that you can, perhaps send some comments or inquiries there, and certainly learn more about how to go about purchasing the technology. Any final thoughts from you guys before we close?
We're all really happy to be here today. Thank you for everyone who's watched. It's real exciting technology, and if you'd love to learn more, we're always here.
Yeah, thank you, everyone. We hope we can work on the future of BCI together.
And it looks like we're running into some technical difficulties with our signal here.
Well, we know all about
so I think we're going to end it there, folks. Thanks you for. I will see you back in February. Take care.
Bye-bye, everyone.